Hello students, welcome to Sreenath Academy. In this video, we are going to discuss Algebraic Expressions and Identities chapter, which is from class 8th mathematics subject and 9th chapter students. So my name is Karthik Tune. We are creating videos on all chapters on all subjects from class 1 to class 12. So please do subscribe our channel, hit the bell icon. So don't forget to like our videos, share our videos. Have a nice day students. Hello, welcome you all to this session. So now we are going to see the overview of this chapter, that is algebraic expressions and identities. What we are going to learn. So what are expressions and terms, factors and coefficients, and monomials, binomials and polynomials, like and unlike terms, addition and subtraction of algebraic expressions, and multiplication of algebraic expressions. There is an introduction for. So in this present chapter students, we are going to discuss mainly about the multiplication of algebraic expression students. Okay, so how to multiply a different algebraic expressions, where main concentration is on multiplication. Why means we have discussed about addition and subtraction in the previous class, in the 7th class. That's why we are going to discuss about multiplication here. And these are the examples we are going to solve. And monomial multiplied by a polynomial. So different types of multiplications means monomial by binomial by polynomial by trinomial, all these kind of things. Latter thing is the identity. So what is meant by an identity? And there are some standard identities. Okay, and how to apply the identity, applying identities. And next, going to solve the examples. So that is the end of the chapter students. Okay, yeah, I think you are interested to complete this chapter in this span of time, short time. So the chapter name is algebraic expressions and identities. Okay students, so we'll start our discussion. So chapter name is algebraic expressions. We will start from the basics. Okay students, so what are expressions, or what is meant by an expression? Suppose if you are having x plus y, it is called an expression. Why? Because means it is having two terms. This is the one term and this is the second term. So and they are combined by addition. So what is meant by an expression? Expression is nothing but combination of two or more terms, and all are combined by plus or minus, by adding or subtracting, not by multiplication or division. You have to remember it. So this is not the case. So if the two or more terms are combined by addition or subtraction, then it is called as an expression students. Okay, and what is a term? We know term is any numerical or algebraic, which means variable, is called as a term. So here x plus 3 is there. It is what? It is an expression. It is x, it is a one term and it is a variable term. And here it is 3, it is a numerical term. And there is 4xy plus 7. What it is? It is also an expression. In this 4xy is what? It is an x, it is a variable. X is a variable, y is a variable. So it is an algebraic term and it is a numeric term. So like that we are having algebraic terms and numeric terms students. Okay, and how to find out the value of any expression, we have learnt about that also. Suppose here what they have given, is there any expression given students? So here there is 2y minus 5, so it is an expression. They have given 2y minus 5, it is an expression. So how to find the value of it? So if y is equals to 2, they have given y is equals to 2. If y is equals to 2, then the expression 2y minus 5 has the value. What is the value of it? That is 2 into y is 2 minus 5. 2 2s are 4 minus 5, it is minus 1. Okay students, so this is the case of finding the values students. Okay, like that we have to find out the values. So we have understood how to find out the values. Number line and an expression. Okay, so what is meant by a number line and an expression? So we know number line and how to represent the natural numbers, whole numbers, all other numbers on the number line. Suppose there is a number line like this. So in this number line we are locating a point x. So there is an x at position x position from the origin O. So if I add 5 to it, that is x plus 5. So it is located at some distance point P, which is x plus 5. And suppose if I want to locate x minus 4, then it must be 4 less than x. It is at this point, x minus 4 is here and x plus 5 is here and x is here. So this is the situation we are having students, like that. And how to represent the number line, the 4x? How to represent the 4x? So it is the number line and here it is the x, so it is represented by a capital X, it is the origin O. 4x means 1 2 3 4, 4 times no. So here it is the 4x. Okay, we name it as C like that. Now we are going to add plus 5 to it. So 4x plus 5. So at this point D we are having 4x plus 5. That's it students, like that we have to do. Now terms, factors and coefficients. Okay, terms, factors and coefficients. So we are taking an expression of 4x plus 5. Suppose if you take the 4x plus 5, okay, it is an expression and it is a term and it is also a term. These two are the two terms. 4x is a term and 5 is also a term. Here the both terms are added so that it get an expression. Okay students, so now if you take a single term, that is 4x, in this single term there are two things. One is the constant, that is 4, another is the variable. One is the constant, another is the variable. So we can multiply constant with variable. So even though if you multiply the constant with variables, all these together, their product will give rise the single term only. And regarding the coefficients, if you see here, so if you take this as the main thing and here 4 is the coefficient and it is a numerical coefficient. Suppose there is 3xy and if you take as 3x as 1 and y as, or simply 3 into xy, then 3 is what? It is the coefficient, numerical coefficient. So if you take as x into 3y, then x is the lateral coefficient, or y into 3x, then y is the lateral coefficient, algebraic coefficient students. So that is the difference between numerical coefficients and algebraic coefficients students. Okay, so next thing is about monomials, binomials and polynomials. So what is meant by monomials? So monomials are nothing but if there is an expression and in that expression there is only one single term, one term is there, then it is called as a monomial. Okay students, suppose in an expression if there are two terms, then it is called as binomial. And in the case of expression if there are three terms, then it is called as trinomial. Okay students, so this is the case. And in any expression there are more than three terms, then it is called as polynomial. That's it students, so simple now. So what is the example for monomials? 2x, 5x square, 10xy. So all these are the monomials. all these expressions are monomials. They are having only one term. Okay, here the examples: 4x square, 4x square and 5xy square. So these are the examples of monomials. Only single term, no plus or minus is there. Coming to the binomials, so a plus b, it is a binomial. So a is an expression, b is also an expression. Two expressions are there. Here two expressions are there and they are combined by plus. That's why it is a binomial. And if another, there is 4l plus 5m. So it is also what? It is also an expression. And it is having two terms. That's why it is also a binomial. And coming to the trinomials, so a plus b plus c, it is having three terms and three are connected by plus, combined by plus, so it is a trinomial. And x square y minus xy square plus y square, we are having no, all these are having three terms. So as these are having three terms, it is a trinomial. Okay students, so this is the case. And polynomials means more than three terms. So these are the examples for monomials, binomials and trinomials and polynomials, students. So we have understood the term, coefficients and expressions and monomials, binomials and polynomials. So we have discussed about these in the 7th class also. We have just revised them. And like and unlike terms. When we say a term is like term and when we say a term is unlike term. Like term and unlike term. Okay students. So normally if you see some expressions 7x and 14x, both these terms are like terms or unlike terms. What you will say? So both the terms are like terms. Why? Because means both are having the same variable. Here the x is the variable, here also x is the variable. So here the power of x is 1, here also the power of x is 1. So both the both the terms are like terms. So next thing is unlike terms. What are unlike terms, students? Suppose if you take the example of 5x square and 7x itself. In these both cases, here the variable is x. Here also the variable is x. That's nice. But here the power to the variable x is 2 and here the power is 1. So the powers are same? No, the powers are not same. So that's why here the powers are not same. That's why these are not like terms. These are unlike terms. So this is the difference between like terms and unlike terms. Like terms will have same variable and same powers to the variable. Unlike terms will have they will not have same powers or same variables. So we will take the example of 7xy and 8x cube z. If you take the example of this, here the variable is x and here also the variable is x, but here the variable having the power 1 but here it is having the power 3. So these are not like terms. And here we are having another variable of y, but here we are not having another variable y. And here we are having another variable z, but here we are not having another variable z. So these two are unlike terms. Unlike terms. So these are not like terms. Okay students, so that is the thing. So just observe here 7x and 7y. Does the both are like terms or not like terms? They are not like terms. Why? Means here there is a variable x and here there is no variable x, and here there is a variable y and here there is no variable y. Here 7xy, that is the same reason, like that students. So now addition and subtraction of algebraic expressions. Addition and subtraction of algebraic expressions. So how to add expressions and how to subtract the expression. Of course, we have discussed them in the previous class. We will just recall them. So if you have 7x square minus 4x plus 5, it is an expression. So there is another expression called 9x minus 10. We have to add these two expressions. How we can do it? So we simply place here 9x minus 10 is there. No, we have to place the like terms under the like terms. Okay, here 7x square is there, but there is no like term for 7x square in this 9x minus 10. So what we have to do here? We have to put 0 here. Next, plus here there is 4x. Is there any like term related to the 4x? Yes, there is 9x. No. And next, it is the 5. Is there any like term? The minus 10. Like that we do the tasks. Now we have to add them. So 7x square plus 0. So simply 7x square. So minus 4 plus 9, which means how to add two like terms? Simply adding the numerical coefficients. So 9 minus 5 is 4. Sorry, 9 minus 4 is 5. No, 5x. And minus 10 plus 5 is minus 5. So this is a way of doing expression, students. So simple, no? And I will do this subtraction. As I am helping you to add, no, I will help you to subtract. So 5x square, we have to subtract this number, 5x square minus 4y square plus 6y minus 3. You have to subtract this from what? From 7x square. I am writing it here, 7x square minus 4xy plus 8y square plus 5x minus 3y. So we have to write this under this expression, and we have to like the like terms under the like terms only. Here there is a 7x square, and there is any like term to this in this expression. So there is 5x square is a like term. And what is the like term for 4xy in this second expression? There is no like term. So simply 0. Plus what is the like term for 8y square in this expression? There is minus 4y square. No, so it is minus 4y square. And what is the expression, like expression for 5x? No, so it is 0. Then what is the like term for 3y? Is there anything? Yes, there is 6y. And there is extra, so it is the constant term, like this. So what we have to do is subtraction. While doing the subtraction, we have to change the signs of the under them. So it is minus, and it is also minus, and it is also plus, and it is minus, it is minus, it is plus. So 7x square minus 5x square means what? It is 2x square. And here it is minus 4xy. And here it is 8y square plus 4y square. It is 12y square. 8y square plus 4y square is 12y square. And 5x plus minus 0, it is plus 5x. And it is 3y. And here it is minus 6y. So it is minus 9y. 6 plus 3 is 9. Next it is minus 3. So this is the resultant of subtraction, students. Like that we have to do. Here it is plus, no? So that is the way of adding, students, and subtracting. So our main chapter concentrates on multiplication. What it is? Multiplication. So now we will discuss about multiplication. What it is, students? Multiplication. So in order to do the task, what we have to do? So basically in the case of expressions, we are having monomials, binomials, trinomials. So what will we do is, first we will multiply the monomial with monomial, and the monomial with binomial, and the monomial with trinomial. These are the three cases. Next we will multiply the binomial with trinomial, and sorry, binomial with binomial, and the binomial with trinomial. So, and next the case is we are multiplying trinomial with trinomial. So these are the types of multiplications we are going to see moving forward. Okay, students. So 1, 2, 3, 4, 5, 6 types of multiplications we are going to understand here, students. Okay. Okay, we will start the discussion. So Before we are going to start the multiplication of algebraic expressions, there is some introduction to you so that you can understand what is meant by a multiplication and how the multiplication of algebraic expressions will be performed. So here there is a pattern of dots. So how many dots are there? Can you guess? Okay, now I will help you. How many rows? 1, 2, 3, 4. Oh, rows are there. Into how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns. There are 4 rows and 9 columns. If I multiplied this number, I will get 9 fours are 36. So I will say that there are 36 dots on this pattern without counting each dot. If you do this, you can find the same. Suppose let us see, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 34, 35, 36. So we are getting the same answer. So like that, by using the multiplication method, we can simply get the answers easily. Okay, so how to do the multiplication is simply total number of dots and that is number of rows and number of columns. If you do for this also, it is also same. Here it is having 5 rows and it is having 1, 2, 3, 4, 5, 6, 7 columns. So it is simply 5 into 7. Number of dots is 5 into 7 dots. Okay students, that is 7 5 are 35 dots. Like that. Suppose if there are m rows and n columns, so what are the total number of dots? It is nothing but m into n. Okay, m into n. Suppose if I increase the rows by 2, that is m plus 2, and if I increase the columns by 3, it is n plus 3. Now what is the total number of dots? It is nothing but m plus 2 into n plus 3 now. So here if you observe this, it is nothing but the multiplication of algebraic expressions. So m plus 2 is an algebraic expression and n plus 3 is also an algebraic expression. Those two algebraic expressions has to be multiplied, so that then only we will get the number of dots here. So this is the usage of multiplying algebraic expressions, and this is the usage of learning algebraic expressions, friends. Okay. Now I will show some practical situations where we apply the multiplication. So now there is a rectangular area, okay students, and whose length is L and whose breadth is B. So what happens is, so it is a rectangle and its a rectangle length is L and breadth is B, and its area is what we know, it is L into B, simply LB. Now its length is increased by 5, so it is the rectangle whose length is increased by 5, so it is L plus 5, and whose breadth is decreased by 3, so it is B minus 3. L plus 5 and B minus 3. Now if we do the task like this, what is the area now of the new formed rectangle? It is L plus 5 into B minus 3. So if we want to know the area of this, you have to do this multiplication, and this multiplication is nothing but a algebraic multiplication. So this is the situation where we really need the algebraic expressions multiplication. So that is one situation, students. And in the case of cuboid also the same will work out. And in the case of buying something, suppose 1 dozen bananas cost is P rupees, we don't know, P rupees. Okay, then if I need Z dozens, how much I have to pay? I need Z dozens of bananas, so it is simply P into Z rupees. Okay, so this is the case, students. Here there is application. P and Z are both algebraic expressions now, and if the per dozen cost is reduced by 2, so now 1 dozen is how much? P minus 2, and number of dozens we have bought is also decreased by 4, so we need only Z minus 4 dozens. So what is the total cost for it? It is nothing but P minus 2 into Z minus 4. So here if you see, both are the algebraic expressions and we have to multiply them, then only we will get the answer. So these are the situations where we have to use the multiplication of algebraic expressions, students. Hope you have understood well. So now we will start our discussion regarding how to do the multiplications. How to multiply a monomial by a monomial. The first case we are going to see is monomial by a monomial, multiplying. So multiplying two monomials. So we will take them. Suppose there is 4 into x. 4 into x. So 4 is a term and x is also term, which is nothing but x plus x plus x plus x, which is 4x. Simply 4x's. So multiplying 4 with x is nothing but writing 4 times the x, and it is simply 4x. How many x we are having? 4x's. And now if I want to multiply 4 into 3x, multiplying 4 with 3x is nothing but, here 4 is a monomial, x is also monomial, 4 is a monomial, 3x is also monomial. It is nothing but 3x, you have to write 3x 4 times, 3x plus 3x. So it is nothing but how much? It is how many x we are having? 12x. 3x. So it is 12x, students. So that is the case. So here we have multiplied the monomials and finally we got this value. Okay. So this is the basic understanding behind the multiplication of 4 into x and 4 into 3x, students. Okay. So we can do further. Here we are having x into 3y. X into 3y. It is what? X into 3y is there. X into 3y can be written as x into 3 into y. So it is can be written as, if you bring 3 into forward, it is 3 into x into y. It is simply 3xy. X into 3y is 3xy. Like that we are doing all these concepts, students. Okay, same example happens for 5x into minus 3 also. I will explain that also. 5x into minus 3y. So 5x into minus 3 is 5 into x into minus 3 into y. If you bring the numbers in the front side, that is 5 into minus 3 into x into y. And if you multiply the 5 with 3, it is minus 15. 5 3s are 15 now, into x into y. We can simply write it as minus 15 xy. So this is the process of doing multiplication. Simply write everything with multiplication symbol, and if there are any numeric numbers, bring them first and multiply those numbers and write the remaining as it is. Okay, students. And here is an example I will explain you. That is 5x into minus 4xyz. Okay, so it is 5 into x into, here it is minus 4 into x into y into z. We can write it as like that. So how to do is, we have to bring the numbers first. So it is 5 into minus 4 into, there is x into y into z. So 5 into minus 4 is minus 20, and there is x into x. X into x is, here x into x is x square y z. So it is minus 20 x square y z. That's it, students. So main thing you have to remember in multiplication of monomial by a monomial is, first look for the numerical coefficients. First multiply the numerical coefficients and write them their result, and write the remaining variables. Okay. And here we are getting, if there is x into x, then we have to write it as x square. And if there is x into x square, we have to write it as x cube. I think you have know all about this. And if there is x into y, then you can write it as, after multiplication, y square. Now, so if there are only two monomials, how to multiply them we have discussed. Suppose if there are three monomials, there is 2x, there is 4x, there is 6x square. In this case, how to multiply them? If you see here, there is a 2x and there is a 5y and there is a 7z. There are three monomials. How to multiply them? So there are two methods in it. I will help you to do the first thing. Here we are having 2x into 5y into 7z. First, took these two monomials and multiply these two monomials and get the result, and the result is also a monomial, and next that result and multiply with this third monomial, then do the same process, you will get the answer. That is the monomial. Okay students, so I will help you. Here 2x into 5x, these two are the monomials. How to multiply two monomials? Simply, first thing is multiply the numerical coefficients. So 2 into 5 into xy into 7z. Next, solve it. 5 2s are 10, so it is 10xy into 7z. Now the three monomials are dropped into two monomials. Now we have to move further, and we have to move further multiplication, so that you will get only one term, that is the monomial. How to do that task? Again same, it is a monomial and it is also monomial. So multiplying a monomial by monomial is so simple, just multiplying the numbers. So it is the 10 and it is the 7 here, into the variables are x, y, z. So 10 into 7 is 70, so it is 70 x, y, z. So this is one way. Here they have given the three monomials, but we take two monomials, we solve it, we will get one monomial, and again later we will take the result and the remaining third monomial, and again they will become the two monomials, and we multiply it, finally you get the answer. What is the another method is, it is so simple and it is confusing also. 2x into 5y into 7z. So what you have to do is, here first take all the numbers, that is 2 into 5 into 7, and write all the remaining variables, that is x into y into z. So 5 2s are 10 and 10 7s are 70, so it is 70 x, y, z. It is simple, but at the same time it requires more mental ability to calculate the fast calculations. So that is the case, students. And here there is another example, that is 4xy into 5x square y square into 6x cube y cube. So in this type of situations we have to use the second method, and you have to must conscious about the multiplication. Here we are having the 4, and here we are having the 5, and we are having the 6. These are the numbers, we are making them as group, and now we are writing the variables. Here we are having the xy into x square y square into x cube y cube. Okay students, so now do the multiplication. 5 4s are, it is 20, and 20 into 6 is 120, so it is 122. Here we are having x, and we are having x square, and we are having x power 3. So here we use the formula, that is the law of exponents. Law of exponents are the rules. What does that tells? If the base is same, then you can add the exponents. Suppose there is a power m and to a power n. Here both the bases are same, that is a. Then you have to write the result of the multiplication of both two as same base and just add the exponents. Like that, here we are having the x power 1 into x square, then it is x power 1 plus 2, and it is x cube. And if you are having one more thing, x cube, simply add them, then it will becomes another 3, then it will becomes x power 6. Like that we have to apply the law of exponents formulas. So if you do that, here there is a x, and here is the x square, and here is the x cube. So x is there, and here power is 1, and here power is 2, and here power is 3. Next there is y, and here power is 1, here power is 2, and here power is 3, and that is the case. So it is 120 into x power 1 plus 2 plus 3 is x power 6, 1 plus 2 plus 3 is y power 6. So that is the way of multiplying more than two monomials at the same time, students. Okay, and here there is an example. Complete the table. We have to complete this table for the area of a rectangle. So there is a rectangle, okay, and its length has given and its breadth has given, and we have to find out the area of it. Okay, how to find out the area of any rectangle? We know the formula is length into breadth, simply multiplying the length with breadth. Here they have given the 3x, it is the length, and the 5y, it is the breadth. And if you go on multiplying it, if you want to get the area, how to do it? We have to multiply it. 3x into 5y. So how we can get it is, it is a multiplication of two monomials. So 3x into 5 means 3 into 5 into xy. So it is 5 3s are 15 xy. That's it, students. So here I will explain you this. It is, there is 2l square m. So it is the length, and there is 3lm square. It is the breadth. So if you multiply the length with the breadth, what will we do? Multiplying the length with the breadth, we will get the area, no? So we want the area, that's why we have to multiply the length with the breadth, and the length is a expression and the breadth is also like expression, and both the expressions are monomials. So how to multiply two monomials? We know, very simple. That is multiplying numbers. So it is 2 into 3. That's it. And there is L square, and here it is L. So it is L to the power of 2 plus 1. And here there is M, and here M square. So it is M into 1 plus 2. So 3 2s are 6, and L cube and M cube. So this is the way, students. Okay, like that, do remaining things. And find the volume of each rectangular box with given length, breadth and height. Okay, so is the example 4. If we do this task, okay, so what is the volume of any rectangular box? Volume, any rectangular box or cubical box, it is nothing but volume formula is, we know the volume of any rectangular, any cubical box is simply length into breadth into height. This is the formula. We have to multiply the length, breadth and height. So here they have given the length value is 2ax, and the breadth value is 3by, and height value is 5cz. If they given the value of length as just 16, 18, 20 or any number, simply we will multiply it by multiplications. But they have given the length values in terms of an algebraic expressions, and these algebraic expressions are monomials. So to get the volume of the rectangle, we have to multiply these three values, and these three values are monomials. So how to multiply three monomials? We know, first we will multiply two monomials, later we will multiply another monomial. It is the one way. Another way is, we will multiply the three monomials at a time. How to do the task? Simply first we will take the numbers. It is 2, multiply the numbers into 3 into 5. We will take all these numericals and we will multiply them. And we will take the variables, that is, here is a, b, c and x, y, z. A, B, C and x, y, z. So if doing so, you will get 5 2s are 10 and 10 3s are 30, a, b, c, x, y, z. So this is the process of doing so, students. So like that we have to do for second and third bits. And so finally we have understand the multiplication of a monomial by a monomial, and we have understood the multiplication of a monomial by a monomial and a monomial. These two we have learned now. Now we are moving further and we are going to learn some more things. What here? We are going to multiply here a monomial by a binomial. This is what we are going to learn now. So how to do this task? Here we are going to multiply, we are taking a binomial which is 5y plus 2. It is the binomial. And we are taking a monomial which is 3x. This is the monomial. Okay, students, and we are going to multiply monomial with the binomial. So how to do? Which is nothing but 3x into 5y plus 2. It is the multiplication and it is the multiplication symbol. So how to do this task? So here we have to use the distributive law and we have to multiply the monomial with each term of the binomial. So in the binomial we are having two terms. So we have to multiply the monomial with the each and every term of the binomial. So that is 3x is multiplied by 5y plus, and again the 3x, the same monomial is multiplied by it is 2. Is it 2, students? 2. This is the case of doing the multiplying a monomial by a binomial. So if I do like that, so it is a monomial and it is a monomial. Monomial multiplication easy. So simply multiplying the numerical numbers. It is 3 into 5, 15. X into y is xy. Plus here there is 3 into 2, it is 6, and there is x, 6. That's it, students. And There is similarly another example is there. Minus 3x into minus 5y plus 2. How to do this type of multiplication? I will help you to do this type of multiplication also. Here the same procedure, students. What we will follow is the same every time. What it is means, here there is a minus 3x and there is minus 5y plus 2. So it is a monomial and it is a binomial. So we have to multiply both these. How we will do the task? We will multiply the monomial with each term of the binomial, that is minus 3x into minus 5y. Okay, this is 1, and plus next again minus 3x into 2. So it is the second thing. Like that we will do the multiplication. So it is a becomes to monomial by monomial multiplication, and the monomial by monomial multiplication is so easy, just multiplying the numbers. So it is minus 3 and it is the minus 5. So it is minus into minus is plus, and 5 into 3 is 15. So 15xy plus, here it is having minus 3x and into 2. So here the number is minus 3 and here it is the plus 2. So minus into plus is minus, so I am writing the minus, and 3 into 2 is 6, so I am writing the 6, and there is the only one variable, that is x. That's it. So simple, students. Like this we will do the multiplication of a monomial by a binomial. So try to do these examples also, students. So next, how to multiply a monomial by a trinomial. Okay, students. So we have discussed the monomial and monomial with binomial, and monomial by trinomial. So the process is same. See here we are taking the monomial as 3p and the trinomial is 4p square plus 5p plus 7. 4p square plus 5p plus 7. So how to do this task? So simple, students. Why? Because means the process is same the process which we followed in the case of binomial multiplication, that is distributive law. So we have to multiply this monomial with each term of this trinomial. As it is a trinomial, it is having 3 terms, and we have to multiply the every term, first term, second term, third term, respectively with the monomial. So it is 3p into 4p square plus it is 3p into 5p plus it is 3p into 7. It is equals to, so 3p into 4p square, how it will be calculated? That is 4 into 3 is 12, 4 3 is 12, and p into p square is p cube, no? So it is p power 1 plus 2 plus here 3p into 5p, it is a monomial multiplication. So it is 3 into 5 is 15, and p into p is p square plus 7 3s are 21 p. So this is the way of multiplying a monomial by a trinomial, students. So, and law of exponents also using here very frequently, and there are some examples we are going to discuss now. And there is example 5 here. Simplify the expressions and evaluate them as discussed. We have to simplify them. How to simplify them? So the first expression they have given is x into x minus 3 plus 2. So this is the expression. First step is we have to simplify it, and next we have to evaluate it, which means we have to find out the value of it. So how to do this task, students? Okay, so by simply doing x into x minus 3 is there. So how we will do this task? We are going to how to simplify it. So there is a multiplication of it. This is the monomial and it is the binomial. So multiplication of a monomial by a binomial, so that is multiply the every term with the multiply monomial with the every term of the binomial. So it is x into x is x square, and minus it is x into 3 is 3x, and plus 2. So it is the simplified form. I have written them directly. And if you substitute, we have to substitute the value, that is if x is equals to 1, what is the value of this expression? So how to find out the value of this expression, students? So we have to substitute the value of 1 in this equation, which means we have to replace the x with the value of 1, that is 1 square minus 3 into 1 plus 2. So 1 square is 1 and minus 3 and plus 2. So here it is 2 plus 1 is 3 and it is minus 3, so it is 0. Its value is 0. Like that we have to do the task, students. And here they have given the two expressions and they asked us to add them. So before we are going to add them, there is a monomial which is the 5m and there is a binomial which is 3 minus m. Okay, we have to multiply them. So it is the monomial by binomial multiplication. So multiply the monomial with each term of the binomial. That is 5m into 3 is 5 3s are 15m minus 5m into m is 5 into 1 is 5 and m into m is m square. And the second term is 6m square minus 13m. So we can't, we need not to multiply it as it is in the form of an expression binomial, simple binomial expression. So we have to add it. So it is 6m square minus 30m. So does the process of answering is completed, students? No, not at all. So if you want to simplify, we have to look for like terms. Is there any like terms in the expression? If there is no like term in the expression, then it is the simplified form. If you see here, there is a 15m and is there any like term for 15m? Yes, there is a 3m which is a like term for 15m. So like terms can be added. So we have to add them. So how we will add is simply adding or subtracting the numerical terms. Here 15 and here is minus 13. So 15 minus 13 into m. And next term is minus 5m square. Is there any like term for it? Yes, there is plus 6m square. So how to do the task? Just simply subtracting or adding the numeric coefficients. So finally it is like that 6 minus 5 is 1. 1 into m square is m square. I am writing it in the before. And 15 minus 13 is 2. So it is 2m. So it is the way of answering the type of problem, students, adding them. So add these numbers also. And I will explain you the example 4. So it is nothing but a subtraction, students. I think you know how to do the subtraction. But here I will explain you how to do the multiplication. Here there is a 3pq into p minus q. So here there is a multiplication of a monomial with a binomial. Process is same. Every term has to be multiplied with the monomial. So it is 3pq into p minus 3pq into q. So simply there is only one numerical term 3 and p square q minus 3pq square. Like that you have to simplify another term also. After doing the same for both and you have to subtract the 2, then you will get the answer. And now multiplying a polynomial by a polynomial. In this, what is the subtopic is, there is a binomial and we have to multiply it with another binomial. How to do this task? Take an example. 3a plus 4b is there. It is a binomial and we have to multiply with another binomial, that is 2a plus 3b. So it is also a binomial. So multiplying a binomial with a binomial. How to do the task? It is so easy, students. Sir, why are you telling it is so easy? It is too hard. No, sir. No, not at all. So the just remember one thing, that is the distributive law, and another thing is the law of exponents. If you just know perfectly them, you will get these things very easy. How to do this binomial by binomial multiplication? It is very easy. So first thing is we have to multiply the every term in the binomial with the another term in the another binomial. That is, you have to multiply this 3a with the 2a and the 3b. Okay, and if you have to multiply this 4b with this 2a and this 3b. So you will get the 4 terms here. That is 3a into 2a plus 3b. You can like this so that it process will be easy. Into, so it is not into, it is the plus 4b. We have to multiply the 4b into this term, 2a plus 3b. So now again it is a binomial and it is a binomial. So it becomes into monomial by binomial multiplication. So each term of the binomial is multiplied with the monomial. So it is 3a into 2a plus it is 3a into 3b plus here it is 4b into 2a plus here it is 4b into 3b. So 3a into 2a is 3 2 just 6. A into a is a square and 3a into 3b is 3 3 are 9 into ab plus 4b into 2a is 4 2 are 8 into ab plus 4b into 3b is 4 3 are 12 into b square. So this is the way of answering, students. So simple now. So if, and next thing is we have to look for like terms. Here 6a square is there. Is there any like term? No. 9ab like term? Yes, it is 8ab. How to add? Numbers adding. 9 plus 8 is how much? It is 17ab plus 12b square. Simple, students. So in multiplication of polynomials by binomials, we should always look for the like terms, if any, and combine them. Okay, students. So at the end, you have to look for the like terms. And I will explain you this multiplication and you will do this. There is x minus 4 multiplied with 2x plus 3. So the process I have told you, first thing is x into 2x plus 3 and minus 4 into 2x plus 3. Okay, now this is the multiplication. X into 2x, that is 2x square, plus 3 into x is 3x, minus 4 into 2 is 4 2 is 8, and x minus 4 3 is 12. Next thing, here 2x square, here 3x and minus 8x are like terms, so it is minus 5x and it minus 12. That's it, students. If you do this also the same way, that is a plus 7 into b minus 5. Same, a into b minus 5 plus 7 into b minus 5. A into b minus 5 plus 7 into b minus 5. So it is ab minus 5a, and here it is 7b minus 7 5 are 35. So if you see, is there any like terms? No, no like term is there. So that is the answer. And now binomial by a trinomial, binomial by trinomial. How to do this? How to do this? So simple, students. Why are means process is same, but it takes some time. That's it. Same distributive law. Suppose here if you take the example of a plus 7 into a square plus 3a plus 5. So what you have to do is, you have to multiply this a with whole and you have to multiply this 7 with whole. That is a into a square plus 3a plus 5 plus 7 into a square plus 3a plus 5. Okay, students. And if you do this, here there is a monomial by trinomial. So we have discussed about this already. So it is simple. We have to multiply a into a and a into 3a like that every time. So a into a is a cube, a into 3a is 3a square, and a into 5 is 5a. Next, 7 into a square is 7a square, 7 into 3a is 7 3 is 21a plus 7 5 is 35. And here a cube is there, and is there any like terms? For 3a square there is 7a square, so it is 10a square, and for 5a it is 21a, it is 26a plus 35. That's it, students. Simplified example 10. I will do this so that it will be easy for you. Okay, so how to simplify it? There is a plus b into 2a minus 3b plus c minus 2a minus 3b into c. So before we are going to subtract these two terms, first simplify this first term and next simplify this term. So the first term is a binomial by trinomial multiplication and the second term is a monomial by binomial multiplication. First we will do this, that is a plus b into 2a minus 3b plus c. How to do? That is a into 2a minus 3b plus c plus b into 2a minus 3b plus c. And again you have to multiply this monomial with every term. If I do like that, a into 2a means 2a square minus a into 3b means 3ab, and a into c is ac, and here b into 2a is 2ab minus b into minus 3b is minus 3b square, and b into c is bc. So this is the term, and we have to look, is there any like terms in it? So there is a square, so 2a square, and is there any a square term? No. And if you look for AB, here it is the AB and here is also AB. So minus 3AB plus 2AB, which is minus AB. And there is AC. Is there any AC? No. Here is a BC. So plus BC plus AC. And here is a minus 3B square. So this is the final term. It is the first term only. And what is the second term? It is 2A minus 3B into C. So it is 2A minus 3B into C. It is the monomial binomial multiplication. So it is 2AC minus 3BC. We have to subtract these two things. So how we can do is, you have to write 2A square minus AB plus BC plus AC minus 3B square. So we can subtract by writing is like terms under the like terms. Another way is just simply writing in the row that's surrounding, that is minus of 2AC minus 3BC. So if we see here, it is the 2A square. There is no A square term here. And if there is AB and there is no AB term, we can write it as. And there is BC and there is a BC term here. So it is the plus BC. And here minus of minus is plus. So plus 3BC is there. So here the 3BC and here it is the BC. So if you add 3 plus 1, you will get 4BC. And there is AC and here also AC. Here the minus 2AC, it is the plus AC. So it is minus AC. And it is a minus 3B square. That's it, students. This is the simplest form of the answer. Like that you have to do. And next thing is, what is an identity? What is an identity, students? How to solve identities? Suppose if you look at this, A plus 1 into A plus 2. And if you multiply these, what you will get is A square plus 3A plus 2. And if I substitute the value of A is equals to 10 in LHS, it is 10 plus 1 into 10 plus 2. It is 11 into 12. It is almost 132. If I substitute A equals to 10 in RHS, that is 10 square plus 3 into 10 plus 2, which means it is 10 square is 100 plus 3 into 10 is 30 plus 2, which is 132. If you see, if I substitute the value of 10 for A, this equation is valid, which means LHS and RHS both are having the same value. If I substitute A is equals to minus 5 and if I do the LHS, in this case you are getting the LH is 12 and RHS is also 12. So what we can say is, for A equals to minus 5 comma 10, this equation is satisfied and the both LHS and RHS are equal. So what we can say is, for any value of A, these equations are satisfied. This equality holds, students. So the equality is hold and it is true for any value of A. Why? Because means, as if you substitute the 10, it is satisfied. For minus 5, it is satisfied. So then it is called as an identity. So if there is any equation, if satisfied for any values of the variables, then it is called as identity. So then A plus 1 into A plus 2 is equal to A square plus 3A plus 2. It is an identity, students. Okay. Suppose if there is equation, it is satisfied for only some values or not every values, then it is not an identity. Okay, students. So that is the answer. Next, standard identities. Here in the mathematics, we are having some standard identities. They are useful for you in the 9th, 10th, 11th, 12th, undergraduation, post-graduation, MSc, MTech, BTech, B.Pharmacy, whatever the stream you are going, whatever the study you are studying in the future in the higher education. At every place, these identities will come. Okay, students. So we have to study them. And what are these standard identities? We have to remember them. So here the first identity is A plus B whole square is equals to A square plus 2AB plus B square. It is the one identity we are having. One of the identity, most beautiful identity, most important and well-known identity we are having. Okay, students. So how to prove it? So we will think of it. That is A plus B whole square means A plus B into A plus B. Sorry, A plus B into A plus B. So a plus b is a binomial and a plus b is also binomial. So it is a multiplication of a binomial by a binomial. How we will do it? That is a into a plus b into a plus b. So if you further continue the multiplication, it is a into a is a square plus a into b is ab plus b into a is ba plus b into b is b square. So if you see here, this is the a square and these two are the like terms. We can add the like terms, then it will get 2ab plus b square. So that is the RHS. That's it, students. And there is another identity, important identity. With which color I have written the identity? Previous case. So another identity is a minus b whole square equals to a square minus 2ab plus b square. It is similar to this only. Here we are replacing the b with minus b. That's it. That is the only change we are having. So b is replaced with minus b. Okay, students. And there is another identity which is a plus b into a minus b is equals to a square minus b square, students. Okay. The identity here we are using is a minus b whole square is equals to a square minus 2ab plus b square. Okay, students. It is so simple. So it is the another identity. So it is got means we are replaced the b by minus b. That's it. This is the thing we have done. Then you will get this. Okay, students. And one more identity we are having is a plus b into a minus b. If you multiply the a plus b with the a minus b, then you will get a square minus b square. It is the another identity we are having, famous and interesting and important identity. It is also a standard identity we are having, students. So now how we are getting this a plus b into a minus b? So a minus b whole square simply you will get by multiplying a minus b into a minus b, or simply replacing b with minus b, students. And coming to the a plus b into a minus b, so a plus b into a minus b, it is also binomial multiplication. So a into a minus b plus b into a minus b. So it is a square minus ab plus ab minus b square. So ab get cancelled, a square minus b square. That's it, students. Standard identities. And now applying identities. So we have to evaluate the volume of 2x plus 3y whole square. How to find the value of this? Using the identity. We are having a plus b whole square is equals to a square plus 2ab plus b square. So here a is 2x. So it is 2x whole square plus 2 into 2x into 3y into 3y whole square. Sorry, plus 3y whole square. So simply 2x whole square is 4x square plus 2 into 2x into 3y is monomial multiplication. 2 into 2 is 4, 4 into 3 is 12 xy plus 3 square is 9y square. So like that you have to solve, students. And here is there is something here, 3m by 2 plus 2n by 3. It is multiplied with 3m by 2 minus 2n by 3. If you see here, it is a and it is b, it is a and it is b, here plus, it is minus. So we know the identity, third entity a plus b into a minus b is a square minus b square. So a is what? 3m by 2 whole square minus b is what? 2n by 3 whole square. So the value is 3 square is 9, m square is m and 2 square is 4 minus 2 square is 4, n square by 9. So that is the answer, students. If you want to simple further, we can do also. And here it is an example of 194 into 206. So we can use these identities for multiplication of numbers also. How to multiply the 194 with 206? So it is very tough now, but I will explain you. It is so simple. We can write 194 as 200 minus 6 no, into we can write 206 as 200 plus 6 no. So how does it is looking? It is the a minus b and it is the a plus b no. So a plus b into a minus b is simply a square minus b square no. So we can simply say it is 200 square minus 6 square. So 200 square is, that is 40,000. Okay, students, 6 square is 36. So subtraction is so simple now. You can do like that, and that is 39,964. So it is the main use of the using identity, students. So that is the end of the chapter, students. So finally our chapter is completed. So hope you have understood well, students. If you have any doubts, please feel free to comment below. We are always ready to engage you, ready to answer your doubts. So we are going to see the summary of this session, students. Expression means it is a combination of two or more terms. So, and regarding the terms, it is having the some variables and some constants. Multiplication is there and coefficient is there, or we are having the numerical coefficients. And monomials means if in an expression there is only one term, it is monomial. If there are two terms, it is binomial. If it is more than two or three terms, it is polynomials. So if the both terms having the same variables and same variable powers, then it is the like terms. Otherwise they are not. How to add and subtract the algebraic expressions? So it's simply the simple thing is we can add and subtract the like terms only. How we can add and subtract the like term is we can just add the numerical coefficients, or we can just subtract the numerical coefficients. That's it, and we'll write the algebraic variables as like that only. And here main our concern is about multiplication of algebraic expressions. So in our real life we encounter many situations we have to apply the multiplication of algebraic expressions. So we have started our journey with multiplying two monomials. How we can multiply two monomials is simply multiply the both the numerical coefficients and write them and write the variables. And how to multiply more than two monomials? So there is two methods. One thing is first multiply two monomials and you will get some monomial and multiply that result with the third monomial. Another method is multiply all the three monomials at a time by multiplying the numerical coefficients, and next multiply the variables. While multiplying the variables, we are going to use the formulas for law of exponents, which means whenever the bases are same, exponents can be added. Okay. And next thing is we have discussed about the monomial multiplied by a binomial. So here we are using the distributive law. So what we are doing is we are multiplying the monomial with each term of the binomial. So like that it will becomes into a monomial by monomial multiplication, and a monomial by monomial multiplication is we know and we have solved them. It is so easy. And next thing is monomial by a trinomial multiplication. Here also the same rule. Multiply the monomial with each term of the trinomial and they will divide into three monomial by monomial multiplications, and it is so simple. Next thing. And after that we have considered the binomial with a binomial multiplication. Here also the same thing, that is we will treat one of the binomial as monomial and multiply the each term of the binomial with another monomial, and you will get the distributive law as it is. And the binomial by trinomial is also the same distributive law. Each term has to be multiplied with the each another term. And identities, which means if there is an identity, whatever the value you substitute in it, so it will satisfy the equation. LHS is the RHS. So standard identities are a plus b whole square equal to a square plus 2ab plus b square, and a minus b square equal to a square minus 2ab plus b square, and a plus b into a minus b is a square minus b square. And applying the identities, we have discussed some problems. So that is the end of the chapter. Summary is also completed, students. So hope you have understood well. Have a nice day. Bye bye.